You know, some time ago, I spoke with a friend of mine, and she told me that they would like to change to cloud. Basically, most of the system, even the production ones, even the databases, and I'm wondering.
The production databases, they want to switch the production database to cloud?
Correct.
This is a known trend. More and more our customers are going to cloud.
True.
But usually when you talk to them, most of them are not thinking about security from a cloud vendor perspective. Have you ever heard about the Capital One case?
No, to be honest.
The Capital One is a bank in US, and they had their all production systems in Amazon Cloud.
Right.
And the former employee of Amazon, who used to work inside the cloud infrastructure, she knew all the loopholes because she was in, right?
Okay.
And she used loopholes in firewalls, backdoors, to steal 100 million of customer data from the bank. Even she used it to implement a Bitcoin mining software to the Capital One servers. Imagine that.
Insane.
And she was arrested only because she bragged about it on Slack.
All right, but the cloud vendors, they claim that the administrators owning the host, right? They do not have access to the virtual machines of the client. They do not have root passwords. They cannot access the machines inside. This is what we hear, right?
Okay. Why do you need a root password? Why do you need access to a virtual machine? Imagine that you are sysadmin at a vendor. Imagine that you have access to the host of all virtual, on which all virtual machines are deployed, right? So, if you have access to the host operating system, why should you have access to the virtual machines, to the guest operating systems? It's not mandatory to go through all the virtual machines and get all the data you want.
So, what is your idea to get into such virtual machine from the, let's say, outside, right?
I don't know. Well, you are an operating system. You see all virtual machines as a Kamil emulator, right?
Processes, right?
You see virtual machine as a process. This is one virtual machine. This is memory of a virtual machine. How do I get access? I don't know. I take a process and get access like that.
Okay. So you are talking about virtual machine introspection, right? VMI. This technique is known for many years now and has been used for examining the vulnerabilities for different forensic stuff, right? You can use it also for examining the memory of virtual machine. That's nice stuff, man. Right.
It should be simple.
Volatility is a piece of software which allows you to extract many information, artifacts, metadata from memory dumps, including memory dumps of virtual machine. This is one of the most popular framework used for virtual machine introspection. It is written in Python, and because of its popularity, it's quite rich in toolset. Basically, it allows you to look into operating system run state. So this is what we try to do. So we have to dump a memory of VM first. So let's take care about this one. VM running here on this KVM host. But let's talk a little bit about how this operating system, this KVM host, sees this VM, and it sees it as just another user space process, right? In that case, we are talking here about Kamil, a quick emulator which emulates virtual environment and device model for that particular operating system VM, and it makes VM basically. And KVM from Kamil perspective, is an enabler for CPU-based acceleration, right? Okay, so let's dump memory from that VM. Because I'm on KVM host, I'm able to do that, to dump a memory live to a file, so without interrupting the VM itself. And we have to remember here that we are trying to deal with one of the most complex pieces of OS implementation, which is memory management system and virtual memory. So to look at the structure of inside memory, volatility has to know how to do that. And to do that, it uses profiles. It has some pre-created profiles already, and as you can see, most of them are in regards to Windows, but when we are trying to inspect Linux, for example, it's always a good idea to build a dedicated one. So let's do that. So let's connect to this VM which we would like to inspect and build a profile from it. So I'm connected to Linux Oracle Enterprise Linux operating system, and in that particular case I'm not gonna use unbreakable enterprise kernel. So let's jump into the volatility, which is already here, and gather required information. While making this, volatility is building a module based on kernel's debug symbols. Then it dumps required debugging information into the dwarf file. Basically, this is a file which supports source level debugging. Because profiles are delivered for volatility as a zip file, let's prepare it. So it has to contain already prepared dwarf file, but also a system map file, which includes symbol tables, also useful with debugging, right? So let's copy that file into the KVM host from which we would like to inspect this memory dump. Okay, so let's clean a little bit here just to make it as it should be. Okay, so we have to put that profile in this particular location, right? So right now let's take a look if volatility sees that profile correctly, and yes, here it is. We have a new profile installed inside volatility. Okay, so let's try to extract some information from our file, right? So memory dump file. So let's, for example, search for information about network interfaces. And voila, here it is.
Okay, let me get this straight. So volatility is just an open source framework written in Python, available on GitHub, and it gives you a possibility to examine the whole memory structure of virtual machine. Exactly. So I can examine processes, shared memories, buffers, everything inside the VM.
Cool, right?
Dude, this is what I was talking about. This is powerful stuff. So as admin, when I do memory dump of a virtual machine, I have access to everything. And do I see correctly that volatility has a -Y switch and it can use Yara.
Yeah.
This malware scanner.
Yeah,
Yara.
you can use Yara scan to basically scan the process of memory for signatures. So that's cool stuff. And to be honest, I can show you something. If you can log into the database and change password for sys, but do not tell me the password, okay? I will show you something.
Okay, now when you're finished, let's see what we can extract from it. So for sure, at first step we have to dump the memory of this virtual machine in which you were changing the stuff, right? So let's dump the memory into the file once again. And we're gonna use the dump and volatility to first extract information about which particular process ID has been involved in your activity. So let's use volatility and let's go through this dump and use Linux PS3 tool to display information about the process tree, right? So I'm interested in a particular process, so SQL plus. So let's see if volatility can find something about that processes. Okay, so it has found 3 different SQL plus processes. I assume that the latest, the highest PID number is yours. So SQL plus is a child of Bash and Bash is child of SSH process session. So let's go through those processes and let's use a Yara scan, as you said, to find particular pattern. So in this simple example, let's assume that I'm interested in looking for a particular command, which probably you could use inside SQL plus. This information can be useful for me as a attack vector, right? For other prepared attack, right? So let's see what it can find about that. The information which it returns are dumps of piece of this address space. So you can see that yes, indeed, you issued that command within this particular SQL plus process and this process ID. Okay, so another interesting thing is to use, for example, a Bash process ID and to display the list of commands from your Bash. So that could be also very interesting piece of information for me. For example, this is another good reason not to use password while you are logging into the database from operating system, right? But let's put aside volatility a little bit and let me show you some interesting stuff. So you can go through the memory dump file just itself and try to find just strings, right? So for example, here I'm interested in looking for any alter user pattern which has been issued from inside that virtual machine, and here it is, just like that. So I even do not have to use volatility to search for strings. So I can clearly see many attempts of password changing. And here it is. This is your password, right?
Whoa, dude! Dude, this is awesome! This is awesome, and I wanted to mess with you, and I typed alter system into the terminal,
Okay.
but I didn't hit enter, and you still have it. You still have it in your memory dump.
Yeah, because every symbol which you type into the terminal, right? It goes through the SSH process and it has to go into the memory. So I got it. That's correct.
It is awesome, and you know what would be even better? Because right now you are doing this based on the memory dumps.
True.
And the memory dump holds a virtual machine for a second. What an awesome idea would it be to do this live in memory?
Yeah, that's a powerful idea. But we are using volatility because it knows the profile of the operating system, so it knows how to search through the memory. So if you would like to do that live, you have to use some kind of tool, and you have to know for what you are searching for. So we have to search for something which is known pattern for us.
Okay, but what is our goal? Our goal is, for example, to steal a tenant's data, right? The tenant's data is stored in database block, which on disk is encrypted.
But it's not encrypted in the memory.
Buffer cache.
Buffer cache.
Exactly. So if we have Yara scanner that can scan memory for patterns, we can create a pattern for a database block.
Exactly.
Let's assume at the beginning that we know the data object ID that we are scanning. Let's use a malware scanner to detect not malware, but Oracle database blocks in memory.
blocks. Cool. Yeah, let's do that.
Hold my
Let's do
beer.
that.
Hold my beer.
Hey dude, do you remember my Rico 2 project that I put on GitHub? So as you remember, it was designed based on BBED tool that was written by Oracle internal support, right? This is the tool to modify and browse the database block in a database file. I modified it a bit to be able to use Yara. And as we talked, I wrote a simple rule for YaraScan to identify database blocks in memory. As you can see, I started with 06A2 because this is the beginning of each database block containing data, and then I have some ambiguous hex information, after which I have the beginning of transaction section that holds information that this is actually a table, and then we have data object ID for the object that we want to attack. So this might be pretty cool. I am going to attack my employees table. And I am going to not only browse my employees table from memory inside this virtual machine, but I am going to change the chairman's salary because I think the dude earns a bit too much, right? So, how to do it? First, I was thinking that, I need to know all data object IDs for all the tables that are inside Oracle database because I don't know them, right? But I know data object IDs of the dictionary tables, right? So let me start from searching for dictionary table called obj dollar, which holds data object IDs for all the tables inside the database. Look what I did in here. So I am starting from creating a Rico object, and I will have to identify a Camel process that emulates memory and hardware for my virtual machine that I am going to attack. And this is that process. I will set PID for Yarascan to 8328. Now I am going to set data object identifier to 18, because in all Oracle databases everywhere, I think 11.204 up, 18 is a data object ID for obj dollar table. Now let me scan my memory for this object. This may take a while. While doing this, of course, we have to know what columns are stored inside obj dollar table, and it is always the same pattern in all Oracle databases. Obj dollar is number for object ID, number for data object ID, number for user that owns the object, and a name of the object. So we have 3 numbers and 1 character. So my row description is number, 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 character. Easy, right? And now I can dump rows for this speed, for this row descriptor, and to the table called obj out. Nice. Now let me check if I have my employees table information in here. Awesome. So my data object ID for the employees table is 73751. Let me modify this and let me search the memory of my PID for a new object. Let me remind you that my guest, my victim operation virtual machine still holds 48,000 as a salary value for this dude. Cool. I found 2 database blocks in memory for this particular data object ID. Let me check the contents of the first one. So this block contains 9 rows, and the other block that I found contains 98 rows. Let's check one of the first rows of my database block. As you can see, the first row contains 11 columns, and I am pretty sure that this is my dude that I'm looking for. How do I know it? Well, man, if you look at the hex data in the Oracle database block as much as I do, you will see not only what data types are in here, but also what data actually are in here. For example, this is 48,000, but to be sure, let me set the row descriptor as number, character, 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 time, character number. Okay, and let's examine our row. Isn't it nice? So I have my Stephen King in here, and I can see that he earns 48,000, and the offset for the value 48,000 is at 12 at byte 1241. If I go to this offset, I will see that 03 means that at this offset the binary coded decimal for Oracle number has 3 bytes and the value is C30551. Cool. So I will go 1 byte further and I will modify the block and I will change C3 to C2. In place. Okay. Once the change is done, I will recalculate a checksum for the database block, because Oracle stores a checksum in the database header, and the checksum is being calculated based on the XOR algorithm. If you want to know what is the actual algorithm for counting database, you can check it on my blog. Okay, so in the meantime, you can check Blogger 600PL. You can find the XOR algorithm for calculating database block in there. But this is not important right now. What is important is reparsing database block to check if I changed my KDBR data for this row correctly. And let's examine the row. Cool, I changed the dude's salary from 48,000 to 480. Of course, those changes are not in memory yet, since this change has been made only in memory of my Rico object. To make it permanent, I will open a file that represents memory structures, memory maps for the process. Bang. And we have to go to the offset where we found our block. Now we can write block data to this offset. Before write, the old value. After write, bang! Stephen King earns now only $480, and that's it. So I was able to go from virtual machine host to the memory maps of the Kamil process, find the offset of database block which resides in buffer cache in a virtual machine, and change it. And this dude in here, this victim database, didn't even notice. Dude, no one knows what has happened in here. For this virtual machine, for Oracle, the value just changed, and that's it. No audit, nothing ever is going to identify it and recognize it as a problem, because the change has been made from below the virtual machine itself. And this database block is encrypted on disk but is decrypted in memory. So instead of trying to break encryption keys, as we said before, we can just attack memory and do whatever we can.
Whoa, that's huge, man. That's huge. We have to defend from it.
You think?
We have to, I don't know, encrypt columns in the database. We have to build honeypots. We have to rethink how we use memory now. Do people know about it?
Do people know about it?
Yeah.
Dude! If we know about it, they know about it. You know they are always listening.
Yeah, right. You and your crazy theories.